on the back of your notes, would you write this down and divide this using long division? Let me refresh your memory. What am I going to multiply this by so it can cancel out a 5x to the third power? So this is going to be 5x squared right here. And I multiply the 5 times the x, and I get 5x to the third power. And I multiply 5 times negative 2 and get negative 10. Please put a squared right there. That should be a squared. Now, at this point, a lot of people were having difficulty with the signs. Let me give you a little help. What I need to do right here is subtract. Subtract is the same thing as changing the signs and adding up the columns. What's going to happen to the 5s? Cancel out, and this is going to bring down a negative 3x squared. Bring down the next term. What am I going to multiply this by so it's going to cancel out a negative 3x squared? Negative 3 times x is negative 3x squared. Negative 3 times negative 2 would get you a positive 6x. What I need to do is subtract. You will make fewer sign mistakes if you think of subtracting as changing the signs and adding up the columns using your integer rules. The 3's will cancel, and this would make a 4x bring down the 8. What am I going to multiply the x by so it's going to cancel out the 4? 4 times x is 4x. 4 times negative 2 is negative 8. Change signs, add up the columns, and everything zeroes out. That was long division. Those of you that did your long division found out that it's tough because it's real easy to make a multiplication mistake. It's real easy to make a sign mistake. The good news is today I'm going to show you an easier way. The easier way is called synthetic division. I'm going to do the exact same problem using synthetic division instead of long division. I need the phones to be put up, please. And so on your paper right here, this needs to be a backwards L. I believe part of that was left off. That's the division symbol for synthetic division. Now, this is the exact same problem, and where did these numbers come from? I'm going to take my coefficients. I'm going to basically do the same problem. I'm just not going to write down all the x to the third powers and x to the squareds because they cancel out anyway. And so I am going to just write the coefficients down. Now, one of the things that is difficult about long division is getting all the signs right, because you have to subtract on every step. And instead of subtracting on every step, I'm going to change this sign one time here at the beginning, and then I'm going to add on all of the columns. I'm going to divide, instead of dividing by a negative 2, I'm going to divide by a positive 2. And here's how synthetic division works. And the steps are all written down for you on your paper. You bring down the 5. Then you multiply 2 times 5 and put it in this column and add the columns. What do you get if you add a negative 13 to a 10? 2 times negative 3 is negative 6, and add the column using your integer rules. 2 times 4 is 8, add the column, and that zeroes out. If that zeroes, that means there's no remainder. This number right here is the remainder. The remainder is 0. Well, I started out by taking the x's out of the problem. I have to finish up by putting the x's back into the problem for my final answer. This is not the answer. Have to put the x's back in. Now, this x to the third got divided by x, and so this answer will always go down by a power of x. If this is x to the third, the answer is going to be an x squared. And this is the answer. Now, would you look at this and turn your paper over and look at the long division? Do you see that it's all the exact same numbers? Just the x's have been left out. So it is a shortcut way. Well, if it's a shortcut way, why didn't I just show you the shortcut in the first place, right? Because this is a whole lot easier than the long division. Would you agree with that? But the reason we show you the long division first is because you can only use the synthetic division on certain kinds of division. This divisor, the x has to be to the first power, and it has to have a coefficient of 1. That's the only time you can use the synthetic division. Now, the good news is that actually comes up a lot in your polynomial problems. So, to use synthetic division, this divisor, the x has to be to the power of 1 with a coefficient of 1. I got it. So, I can use synthetic division. For my synthetic division, I write down the coefficients without the x's. And my divisor here, this has to change signs. Instead of dividing by a +3, I divide by a -3. I skip a line here to write down my division, and I draw a line so I can keep everything all lined up straight. You start by bringing down the first number. You multiply the -3 times the 2, and that will give you a -6, and you add up the column. You multiply -3 times -3, and you get a +9, and you add up the column. -3 times 5 will give you -15, and you add up the column. A 0 over there at the end means the remainder is 0. That's not the answer. You have to put the x's back into the answer, and it always goes down by a power of 1 because you divided by x to the first power. So this is going to be 2x squared minus 3x plus 5. That is your answer to the division problem. Next problem. You write down your coefficients, the numbers without the x's, and you divide by not -2 but +2. You change the sign on this one, and that is your divisor. You skip a line, you make a line. You bring down your first number. -2 times 3 is +6. You add up the column. Be careful with the signs. If you add that up, you're going to get a 2. A +2 or a -2. Multiply, and that will give you -4. Add up the columns. Multiply the 7 times the 2, and that will give you a 14. That makes a remainder of 0. This is not your answer. You have to put the x's back into your answer. If this is x to the third power, this is x squared. This goes down by a power of 1. This is your answer because you don't put plus 0. Can you try the next one, please? When you divide, that's what you get, but this is not a remainder of 0. That means it didn't divide evenly, but what is the answer? This goes down by a power of 1, 3x squared minus 7x plus 9 with a remainder of 10. What do you do with the remainder? Well, way back there in elementary school, hopefully you learned that the remainder can go over the divisor. That is how you write the answer with a remainder. And we're going to be talking about in the next unit what this remainder, what is that? What does it look like? Well, how does it look when you graph it? That's coming up next. Now, the next example is missing some of its terms. Does it have an x squared or an x to the first power? So before we do our division, we have to understand that this is equal to x to the third power plus 0x squared, no x squareds, plus 0x plus 27, and that's what I need to divide by x plus 3. If there is a term missing, I have to put in a 0 coefficient. And so this is going to be 1, 0, 0, 27. And I'm going to divide that by negative 3. Remember, this always changes sign. I'm not going to divide by positive 3. I'm going to divide by negative 3. Skip a line, make a line. Bring the first term down. Negative 3 times 1 is negative 3. Add up the column. Negative 3 times negative 3 would be positive 9. Add up the column. That's a positive 9 times a negative 3. Negative 27. That zeroes out. It has a remainder of 0. This goes down by a power of 1. That's 1x squared minus 3x plus 9. Do I need that 1 out in front? We don't need the 1 out in front, and so this is our final answer. Would you agree that this is much easier than the long division? Now, why did I teach you the long division anyway? This example is not on your paper, but this example could not be done with, well, it couldn't be done very easily with synthetic division because the coefficient here is not 1. So this kind of problem would have to be long division, and you need to do worksheet 12.8 and worksheet 12.9 due tomorrow.